Hey guys, so today we're going to learn about how to verify if a function is actually a solution to a differential equation. If you are uncomfortable with integrals or derivatives, you can check out my other video going through step by step how to take derivatives, take integrals, because those are key skills that you'll need in order to verify functions. So without further ado, let's hop right into the first example. Let's take a look at our first example here. We are trying to verify that y of t equals e to negative t plus t divided by 3 is a solution of the differential equation described here. So another way of thinking about this question is, if we choose y of t equals e to negative t plus t over 3, and we take the fourth derivative, the third derivative, and then we keep plain old y, will we get negative 3 e to negative t plus t in this equation? So that's what we're trying to verify here. So naturally, the first step is to take derivatives. We know that we're going up to the fourth derivative of y as given by a differential equation, so we need to take the derivative of y 4 times. The first derivative of y is going to be negative e to negative t. We're using the additive property here. So we're taking the derivative of e to negative t first, and then we're going to have plus 1/3 because 1/3 is the derivative of t over 3. And we repeat this process for the second derivative, third, and fourth. So now that we have our 4 derivatives, we can plug them into our differential equation and go on to verify. So plugging in now, we have our equation, fourth derivative of y, which we're going to plug in from here, and we know that it's e to the negative t. Then we have our third derivative of y, which is negative e to the negative t, and we're going to plug that in here, making sure we distribute out our coefficient of 7. And finally, we have y, which we get from our solution, and we plug that in here, again, making sure to distribute out that coefficient of 3. So we end up with this equation where our fourth derivative of y is here. Our third derivative of y is this negative sign because we keep that, we're distributing that. And then our e to negative t. Finally, we have our y. It shows up in this e to negative t and this t here. I did a little simplification. So if we distribute out 3 times y, we get 3 times e to negative t plus 3 times t over 3, which simplifies to simply t. And the question we're asking here is, if we evaluate this, do we end up with negative 3 e to negative t plus t? We're getting that here. So let's go on to verify to see if this solution works. Now we are tasked with verifying if our solution works for this differential equation. So if we simplify what we plugged in on the previous slide, we can add like terms and verify if this equals negative 3 e to the negative t plus t. So we have, these are like terms based on their e to negative t, and then we're left with t. So 1 e to negative t minus 7 e to negative t plus 3 e to negative t gives us negative 3 e to negative t, and then we have our t. And that's how we get our simplification here. So from this, we can say that y of t is a solution of the given differential equation, and we were able to verify that. Let's try another example. Again, using the same concepts. We have a solution that we are trying to verify that is defined by this equation of a differential equation defined by the first derivative of y minus 2t times y equals 1. We know that we are only taking the first derivative of y using our differential equation, and that the first step is to take derivatives. Taking the derivative of our solution, we end up with this function. Again, if you are not comfortable with taking derivatives, doing integrals, please check out my other video where I go through derivatives and integrals of both regular functions, complex functions, all kinds of great stuff. Moving on, step 2 is to plug it into our differential equation so we can move on to verify. So if we plug in our first derivative from this equation and we put it into our differential equation and we subtract 2t times y, where y is coming from our solution defined in our problem, and we stick it right in there, making sure to distribute out our 2t, we end up with this equation. And again, our first derivative shows up here, and the next part of our equation with just our regular y shows up here. Keep in mind, be very careful when distributing out your coefficients because this negative 2t shows up both here as well as here. And finally, we are setting it equal to 1 because we're taking that from our original differential equation. Now we have to verify if this simplifies to 1. So now verifying, if we simplify the equation we created by doing the plugging in, off the bat we can cancel out those two integrals. So we are left with 1 plus 4t e to the t squared minus 4t e to the t squared. Those 4t e to the t squareds also cancel out and we're left with 1. So again, we can say that y of t is a solution of the given differential equation. Verifying differential equations is the first step when tackling problems. After this, you can find general solutions, particular solutions, go on to partial differential equations, things like that. If you are interested in learning about those topics, again, feel free to check out my other videos on that, where I go through specific examples and take you step by step through the process.